To produce solar racking on site with portable roll-forming technology, we need to design a rack profile that is thin enough to be roll-formed, yet sturdy enough to withstand Mother Nature, specifically snow load and wind uplift. Finite element analysis, FEA, was used to design the rack profile. FEA works like this. First, a 3D computer-aided design model of the racking system is created. The model is then divided into a fine mesh of small, contiguous elements, each connected to its neighbor. With a fine enough mesh, the complex differential equations that describe deformation under external forces like snow load or wind uplift can be replaced by simple-to-solve linear equations. Let's look at the displacement and how the system flexes under pressure. The color scale denotes displacement from blue to red, blue being 0 flex and red being ½ inch flex. First, watch the effect of 50 pounds per square foot down pressure, snow load, on the solar panel. As the pressure increases from 0 to 50, the solar panel, rack, and clamps flex. The solar panel flexes the most, while the clamps and rack also flex minimally. Next, watch the effect of a 25 pounds per square foot uplift pressure. Again, as the pressure increases from 0 to 25, the panel undergoes most of the displacement. For both the 50 pounds per square foot down pressure and the 25 pounds per square foot uplift pressure, the extent of flexing is acceptable. Now let's look at internal stress. The color scale denotes internal stress, blue being 0 and red being 10,000 pounds per square inch. First, the effect of 50 pounds per square foot of down external pressure on the solar panel. As external pressure increases from 0 to 50, you can see the internal stress changes in the solar panel, rack, and clamps. Remember, in the previous displacement animation, the solar panel flexes more than the rack. Internal stress behavior is opposite. Internal stress in the panel is relatively low, and the rack absorbs most of the internal stress. Furthermore, internal stress rarely exceeds 10,000 psi, significantly less than the rack metal failure point of 60,000 psi. Next, the 25 pounds per square foot external uplift pressure. Again, the solar panel has minimal internal stress, while the rack and clamps absorb most of the internal stress. The stress rarely exceeds 10,000 psi, and there is a significant safety factor. Roller rack. Thin enough to be roll-formed on site, yet sturdy enough to withstand snow loads and wind uplift. Learn more, or look into the RollerRack beta testing program for installers at rollerrack.com or call 216-391-7400. RollerRack research funded by the U.S. Department of Energy Solar Energy Technologies Office.